Alrighty then, I think I have this set up. It's a lot more complicated on the mechanical side, but let me see if I can get through this without confusing you too much. So let's start with the LB and the fixed support shaft coming out of it. And a comment I should make is that over time, I've tended to use 632 set screws to hold these things in place. And part of that's because, you know, I make so many different styles of them and I reuse them and that sort of thing. But part of it's just kind of dumb. The best thing to do is just to go ahead and glue these things together and move on. And I'll show you why. I'm trying to eliminate those set screws, and if I can do that, I can get it down to one screw size in the whole required in the whole package. And let me show you what those screw sizes are. It's a 4mm screws. There's 4 of them required to hold the motor, or hold this. To hold the motor onto this top cover. And there's also 4 of them required to hold the motor coupling onto the end of the movable shaft. And there's 2 different sizes there. There's a 4mm by 16mm, which is that guy. And then there's a 4mm by 8mm, which is this little guy right here. And as far as that goes, that's it. So it keeps that pretty simple for you, and you don't have to spend a fortune buying screw assortments. And the one thing I was not able to figure out and get away around is there's a 632 set screw right here. I think we better do that one. And gluing here wouldn't. I don't think it would hold. So it's better to go ahead and put that set screw in there. I hate it, but and when it comes down to that, let me show you something that is pretty handy for me. Well, I have to apologize for not being prepared to show you this. I wasn't planning to. Well, shoot. Hold on just a minute and I'll get this done. There we go. For working around this general stuff, these little combination drill and tap assemblies, I've got one side is metric and the other side is imperial. It's really handy, especially with sheet metal or light duty aluminum, PVC, that sort of thing. Our downshaft is complete at this point. But what we need to do then is transfer this location, this center location, up into this cover, so we have a place for our shaft to come through at the top. And the way I do that is just with this transfer screw, I just slide it up through here, and then that'll give me a prick punch mark right on the underside of that cover. Then I drill that to 5/16 and I'm good to go. Now you will have to, I think I probably mentioned this in the PDFs, you will have to sand this some just to get a good slide fit. But when you get this all set up, boy, she's rigid as heck. And you've got good alignment there. The next thing that gets a little bit complicated is how do you attach the motor, first of all, to this shaft, and then again to this plate. Now, I use transfer screws. I don't know, but you don't have to. Again, you could use just put a small screw down in there and use some nail polish, and you slide this up against there, just anything to give you a mark, and they don't have to be all that close. Just anything so you got enough clearance to get that screw down through there. And the transfer screws, if you're not familiar with them, they screw down into that 4mm hole, and then they provide a way that I can prick punch that once I hold it up against it. Now I did have to, on the way the motor comes up through there, for this is where the direction indicator mounts, and I had to drill that out with a number 7 drill and tap it to quarter 20 in order to and drill and actually drill out the top of that that direction indicator for it to fit. But you may not even want to use that. You know, you can use whatever other devices that you may want to use up there. That may just be too much sugar for a nickel. You also will need some spacers when you mount this, because this part needs to go against up against the cover. So you'll need spacers there. I have a bushel basket full of them, but these you can get at Lowe's. You know, they're not hard to come by. And once you know that you've have to go, at least I can give you a heads up enough that you'll maybe only have to make 1 or 8 or 10 or 12 trips. And so let me think. At this point, we've got it assembled. And you know what screws you got to have. I'll go back to that again. You need 4 of a 4mm by 16, 4 by 4mm by 8, and you'll need at least one 632 set screw, and that's about it. I realize this is kind of disorganized, but I found a little slot this afternoon where I could find time to do this, and I just want to get it done to try to help you out. This is just a little update video on some changes I've made to the rotating shaft. By way of giving you background, I've had a problem with the rotating shaft loosening up from its connection to the drive motor, and it seems to stem from the fact that all of the weight of the shaft is on that one set screw that goes onto the flat on the drive motor. So in order to remedy that, I have redesigned this end, and it now has a, as you can see, a stainless steel washer here, and then on the bottom side, I have a thrust bearing that captures this entire shaft inside the stationary shaft, so that that weight is now supported. But the only thing this set screw has to do is just to cover the rotation, which is the way it should have been to start with. I made a couple of other changes. Let me see if I can slip this out of here without making a mess. There's the shaft, or excuse me, the washer. First of all, this is a new piece. I'll put a new description for this, and it's a flange washer with the 5/16 ID. I'm sorry, it's not a washer, it's a bushing. A 5/16 ID bushing with the flange, and it's a 1-inch OD. Now, you notice I have a little Teflon tape on here. This is about 1 inch and 20 thousandths, and I need to take up as much of that space as I can, just in order to give us every shot we can at maintaining concentricity there. This comes with 2 set screws 90 degrees apart. One of them goes into the shaft on the flat. The other one is taken up by the switch actuator. So I added 2 more so that now we can get 3 on there. I just want to do the best I can to get all that, to get that as stout as I can against that connection. Looking at this, this is how I hold all this together in order to transfer and tap these 4mm screws into the top of that flange in order to hold everything in place and at the same time make it concentric. So This gives me a little better than the other method that I was using. Gives me just a little bit better shot at keeping everything concentric. Now, the one thing I haven't shown you here, once I put this all together, I use 3 832 set screws drilled in through here and deep into this bushing, and I space those 120 degrees apart to kind of equalize that load. And but I drill into there. You'll notice this is pretty thin, so I drill and tap both of them together so that the set screw is engaged in here and in here at the same time, and use a 832 screw set screw to do that with. The only other change that I've made is on the other end of this shaft. This washer, or this plug that goes up in here, it's a good fit, but it's not watertight. So I was getting some water in there. The only thing I've changed is that I sealed this off with silicone glue. I just made a good, I just dabbed. I made a good mess all the way around it. I'm going to pause for a moment and go out and show you how all of this assembly goes together. Thank you. I decided to shoot this part of the video on the boat because I had already replaced my unit, and I didn't want to take it back off just to shoot this. And what I'm wanting to show you here is that I did have to modify this LB to give us a clearance hole to be able to reach in with and attach the motor drive shaft to this coupling. And through here you can see this is actually the top of that flange bearing, and underneath that flange bearing is the stainless steel washer that bears against the top of that rotating shaft. And then I have a plug that I pop into there and cover that hole up. So now this is the other part that I added. This being a thrust bearing, a roller thrust. No, it's not a roller thrust bearing. But it is a thrust bearing. And then this collar captures it. So now we have that rotating shaft completely captured axially, and takes the entire. So it's taking the load off of that set screw. All that set screw is doing now is rotating the shaft, which should have been that way from day one. The other reason I wanted to do it out here is this support. Background on this is last weekend I made about a 15-mile run in a pretty severe chop, and it literally beat this thing to pieces because I forgot this. I left it at home. And you can see how this is made. I think I've talked about it before. It's nothing more than an 1.5 inch T, 1.5 inch by 1/2 inch. So I just cut this in half. I have a 1/2 inch piece going down, and then there's just somewhere over there, if I can get to it, that shows you that I just put a fitting down there that give me something for a foot for it to set on, and then I figured out a way to clamp it onto here. So as long as you have this and the modifications that we've just made on here, everything should be good. The key here is don't leave home without it.